Hello, am I audible? Thank you for the confirmation. So we will be waiting for a few minutes and then we'll continue with our session. We'll just wait a few minutes while other participants to join as well.
Hello. Good evening, ma'am.
Rakesh, should I start?
Ma'am, 5 minutes, can we wait? So participants are joining.
Okay.
Yes, ma'am. So actually, she is going to introduce you. Oh, sorry, he is going to introduce you.
Okay. Sure.
I think we waited enough and it is about time so that we start our session. I'd like to start with greeting everyone. First of all, our respected speaker, Dr. Sriparna Saha. Ma'am, and all the dear participants, very good evening to one and all. Let's start with introducing our speaker to us today. So it is my pleasure to introduce Dr. Sriparna Saha, a distinguished faculty member from IIT Patna, who will be leading our sessions on NLP applications, chatbots, and machine translation. Today's session will explore how NLP powers real-world applications such as chatbots and language translation systems, bringing human-computer interaction to life. I'd like you all to give a virtual welcome to our respected speaker, and I'd like to thank our speaker for taking time from her busy schedule and giving her insights on such an important topic. I'd like to welcome you, ma'am, and I'll request you to please share your screen so that we can start with our session for today.
Thank you. Thank you. Thank you, Ishita. Is it visible now? Can you see my screen?
Yes, madam.
Yeah. So should I start?
Yes, yes.
Okay.
Uh,
Yeah.
is it only
Yes.
me, ma'am, you're not audible, I think. Please, can
I'm
anybody confirm this?
not audible. Hello.
You are audible, ma'am. You are audible.
Okay. Ishita is saying I'm not audible.
Yes, yes. Now audience also saying there you are audible.
Okay. Okay.
Yes.
Okay. Okay. Fine. So yeah, this 2 hours lecture is divided into 2 modules. So first of all, I will be discussing about the theoretical part, and then Just one sec. Rakesh, am I audible? Rakesh, hello.
Yes, madam. Yes, madam. You are audible.
Okay. Okay, sure. Yeah, so this 2 hours lecture is divided into two parts. So in the first 1 hour, I will be discussing about the theoretical components of the talk. Like I will discuss about some of the application areas where we are trying to develop some chatbot. So how we are developing some chatbot, what are the main components of the chatbot? So that I will be discussing. And in the second part, one of my student will show you some demo on this particular topic. Okay, because nowadays the large language models are very popularly used for as a chatbot. So he will show you on a demo on the on large language models. So yeah, I am Dr. Sriparna Saha, currently an associate professor in the Department of Computer Science and Engineering, IIT Patna. So my email is sriparna@iitp.ac.in. So if you have any doubt, you can always reach me in this email address. And this is my also home address, homepage www.iitp.ac.in tilde Sriparna. So yeah, so let me start. So basically, conversational AI is becoming very, very popular nowadays because, nowadays we are starting our day with Alexa or Siri, and Alexa and Siri are nothing but the conversational agents. So they are listening to us and they are answering to all our questions. So you know that, and if you compare the market of these conversational agents, so in 2018, 30% customer interactions are via emerging technologies. In 2020, 5 billion, this is the size of the global conversational AI market in 2020. And in 2022, 70% customer interaction via emerging technology. And in 2025, 13.9 billion expected size by at a CAGR of 21.9%. So virtual agents are of different types. There are some personal assistant like Alexa or Siri. Then there are some virtual assistant, virtual chatbot in the healthcare domain. Like you, we can also develop some virtual doctor who can help the doctors in diagnosis. Then there are some there are some chatbots which can help in the maybe in the counseling. Like if suppose you are suffering from some mental disorders, a student is suffering from some depression or anxiety, so they need some counseling services. So nowadays there are many chatbots which can also provide some kind of counseling services. Then there are some chatbots which can also help the help the shopkeeper to sell a particular product. So if there is a Amazon website, online website, there are many e-commerce online websites where we can express our requirement, and there are many chatbots which will help you in selecting the product, and then they can do the persuasion and negotiation on the purchase of the product. So this way there are different types of chatbots nowadays available. And when you want to develop the chatbot, either we can develop it a modular wise, because the chatbot can is having multiple different sub-modules. So we can develop the modules one by one, or we can develop the modules in a scratch, like end to end. So because we have now the deep learn generative AI techniques or the deep learning based techniques, so end to end also is also possible. Or the other possibility is that we have the multiple sub modules, and we can develop the sub modules one by one. So you know that human learning and data, so data alone is not enough. So we need to somehow infuse the some kind of intelligence into a model. So we need to build AI that captures how humans think. So basically, we need to infuse some kind of intelligence into a model. The data is not enough, so there are enough evidence on this. So example of 2016 election, all data, all polls, all the social media, all the news articles would still not have predicted the correct outcome. A combination of data and human insights, the time, geography, demographics allowed the correct outcome prediction. So humans do not rely on data alone. So basically, what we are trying to do is that we are not only using the data, but we are also using the human intelligence, human like intelligence, like how humans think or how humans try to solve a particular problem. We are trying to infuse the human like intelligence into building a chatbot. Okay, so I will show you how we are doing this. So that is the main purpose, that you know that when suppose there is a particular task in hand and the chatbot, can you please mute yourself? Someone is talking.
हाँ वो हॉल में देखना है कि
Uh,
सारे चेयर्स अच्छे से हैं कि नहीं। कौन से हॉल? विवेकानंद और पानी
uh,
वानी का।
Rakesh, someone is continuously
ड्यूटी लगा है,
talking.
मेरा एग्जाम ड्यूटी लगा है। एग्जाम ड्यूटी? हाँ। कौन सा?
Oh, ma'am, I'm looking into it. I'll just mute them.
पे
Sorry
लगा है
for
मेरा
this.
मेरा इस पे नहीं लगा है।
Yeah. So, you know that as I mentioned that there are different types of chatbots, and task-oriented chatbot means there is a particular task in hand, and we want to solve that particular task only. So this is called the task-oriented chatbot, and and as I mentioned that we want to infuse the human intelligence into this kind of chatbot design. So let me show you the different types of. Yeah, so these are the two different types of chatbots that you can see. So the left hand side is the task oriented chatbot. So suppose here the chatbot is mostly responsible for solving a particular task. Like maybe we want to design a chatbot which can help the user in booking a particular bus ticket or a train ticket. Okay, so you have to mention all the necessary details like the train destination, train departure, time the train should arrive by, time the train should leave by, day the train should run, intent description. So everything you have to mention, and then you know that there is a chatbot which will basically try to book the ticket for you. So could you help me find a train to Cambridge on Wednesday? Sure. What station would you like to leave from? And when would you like to depart? London King's Cross. I was wondering if there are any trains that arrive by 3 p.m. So this, so you know, there are these are the three. This is a kind of a virtual assistant, which is trying to develop, which is trying to book a, but bus ticket or the train ticket for the customer. So this is an example of a task-oriented chatbot. On the other hand, you can see on the right hand side, you can see open domain virtual assistant, where we are simply chit chatting with the chatbot. Like suppose the customer is having a particular issue, like maybe the mental issue, or simply the customer is discussing on a particular problem. Like user is saying, hello, how are you? Agent is saying, I am fine, heading to school. User is saying, lovely weather today. Agent is saying, it's bit too chilly for me. User is saying, you don't like autumn. Agent is saying, nope, I prefer summer. So this way, there is a casual conversation between the agent and the user. So this is an example of a open domain virtual assistant. So as I mentioned that these are the various components of a dialogue system. So first of all, before answering the user, the dialogue agent has to understand what the user is trying to say. Suppose user has user has mentioned some utterance. User said something that how are you? So before giving the answer, the chatbot has to first understand what the user is trying to say. So there is an automatic speech recognizer. The automatic speech recognizer will basically identify the speech. So basically we will identify the speech signal, and then there is a natural language interpreter, NLU module. So natural language understanding module will basically translate the speech signal. NLU module will try to understand what is the communicative intention behind the dialogue, like whether the user is asking a question, or it is a greeting, or it is an open question, or what is the communicative intention behind the utterance. Okay, so that is the task of the natural language interpreter. And then there is a dialogue state tracker. So like there are many there are many it has to extract all the important information from the utterances, and all the important slots and also important actions from the dialogue state tracker. Then there is a dialogue response selection, and the natural language generation is the most important part. Like now based on the extracted information, the chat this the bot has to generate a response. So these are the various components of a chatbot, and now we can either develop one by one, or we can develop in a modular way. Okay, we can develop in a end-to-end way. So there are two solutions. So we can either develop in a one by one, like we can develop individual modules one by one, or we can develop in a end-to-end fashion. So this is the way to build a conversational assistant. So basically I will so let me show you all the modules one by one. Suppose there is a utterance, show me cheapest flights from Pittsburgh to Denver. So here the user is giving a command. So the dialogue act classification or the natural language understanding module that will give the output. Dialogue act classification will be command, because it is a sentence level prediction, and here the dialogue act is basically the command. Show me cheapest flights from Pittsburgh to Denver. So here the sentence level prediction is basically the command. Now the intent is basically the flight plus airfare. So the intent is what is the intent? So flight is the intent and the airfare is the intent. So there are two intents. Flight is an intent and also airfare is an intent, because the user is interested in knowing the flight ticket, and also user is interested in knowing the airfare. So there are two intents, flight ticket and the airfare. So this is the intent, and the slots are basically the Pittsburgh and Denver. These are the two slots. So that if you will do the slot filling, you will get the B from city and the B to city. So Pittsburgh and Denver are the two slots. So now there is a dialogue management strategy. The main function of the dialogue management component is to control the flow of the dialogue, typically mapping states to action to achieve a predefined goal. Okay, so basically we have to basically map the state into action. So the state is basically a all the slots that are extracted in the previous in the previous we have in the previous module we have extracted all the slots, and now all these slots will be mapped to the action. So that is the dialogue management strategy. So the main function of the dialogue management component is to control the flow of the dialogue, So typically mapping states to action and to achieve a predefined goal. So yeah, and then there is a natural language generation module. So the natural language generation module will basically generate the next action. Okay, what will be the next action of the chatbot? So who is the director of Titanic? If this was the question of the user, now the chatbot has to give the answer. So chatbot will generate the response. So how to represent this information to the user? So user will generate the answer, that the James Cameron or the director of the Titanic is James Cameron. So presenting the information to the user in natural language is the task of the natural language generation module. So these are the various components of the, as I mentioned, that building a chatbot is not so easy. So there are many components involved, like this is the overall picture of the chatbot. And you have two options. Either you can build one by one. So for each module, we can either develop a classification module or we can develop end to end. So basically now I will discuss some, like I will show you individual, how we are building the individual components. Okay, because initially people were focusing on developing the individual components, but with the introduction of generative AI and the deep learning technologies, people have started developing it end to end. So let me start with the first work, applications of multimodal information processing in NLP towards emotion-aided multimodal dialogue act classification. So here, that so basically this is the in this particular work we have developed a multimodal version of the we developed a multimodal version of the dialogue act classifier. So as I mentioned, the dialogue act classification is the first submodule where we are trying to identify the communicative intention of the utterances. Like user is saying something, what is the communicative intention? Whether this is a command or statement or the expression or the greeting, what is the communicative intention of the user's utterance? That is called the dialogue act classification. So we need to understand, we need to identify the dialogue act of a particular utterance. So basically what we have done is that we have in this particular work we have shown that if we are simply seeing the textual utterance, then maybe that is not enough. So we need to also see the text, users audio or the videos, and users facial expressions, and then we have to determine the communicative intention of the user. So maybe only the text is not enough, but we need to see a combination of text, audio, video, and the other signals. So that was the main contribution of this particular work. So to identify the communicative intention of a speaker in a dialogue conversation classified into a predefined category. So this was the dialogue act classification to identify the communicative intention of a speaker in a dialogue conversation classified into a predefined category. So there are different types of dialogue acts. What kind of experience do you have then with the child care? This is a question. I think it is really, this is a statement. How about you? This is an open question. That's all right. This is an understanding. So these are the different types of dialogue acts. And we classified into 20. I will show you there are 21 types of dialogue acts. But in this particular paper, our main contribution is that we are not only using the textual utterances, but we are also using some other modalities. Like our main motivation is that the change of tone, the facial expressions, these can also provide some useful information to identify the dialogue acts. So thus stressing the role of incorporating multimodal inputs into the task. Like suppose when someone is saying okay sure or yeah right, then the okay sure can be a agreement or can also be disagreement. But how to understand whether okay sure is agreement or disagreement? So this depends on the other modalities. Like okay sure can be agreement or disagreement. It depends on that we can easily understand it from the facial expressions or the body movements or from the audio tone. So that's why in this particular work we have also incorporated the audio information and also the facial expression. So the another important thing is that maybe the text information is not in, maybe the only we are solving the dialogue act classification, that is not enough. Sometimes we also need to consider the emotional state of the speaker. So for example, if the speaker is saying okay sure and the speaker is very happy, then this is a sign of an agreement. But if the speaker is saying okay sure and the speaker is sad, then this is a sign of a disagreement. So this way, the emotional state of the speaker is also a kind of a clue whether this is an agreement or a disagreement. So mostly in expressive dialogue acts such as greeting, thanking, apologizing, etc., speakers' emotions can assist in recognizing communicative intention. So what we proposed is that we proposed a multitask-based architecture where there are multiple tasks, emotion recognition, and the dialogue act classification. And also there was no data set available in order to train the deep learning based model. No data set was available, so we prepared a new data set called the emotida, and this is a high quality annotations of dialogue acts and also emotion tags. And we solved two tasks simultaneously: emotion recognition and the dialogue act classification. And yeah, and then yeah, so our main task is the dialogue classification and our auxiliary task is the emotion recognition. So this is our emote data set. So in the emote data set, there are we use 12 tags: greeting, question, answer, statement, opinion, statement, non-opinion, apology, comment, agreement, disagreement, acknowledgement, back channel, and the others. So these are the 12 tags that we have used. And you know that and also what we have used to remove the discrepancy in the number of emotion tags for IMO cap and mail datasets. The joy tag of, so basically we have merged two datasets. So when we were searching for the dataset to train this particular model for this multimodal dialogue act classification model, you know, there was no dataset available which is annotated with the dialogue act classification. So we were searching for some dataset and then we found out there is a IMO cap and mail dataset which are annotated with the multimodal emotion tags. Okay, these two datasets are multimodal. There are three modalities present: text, audio, and the video. And these the samples are annotated with the emotion tags. So what we have done is that we merged the datasets IMOCAP and mail, and then we annotated these datasets with the dialogue act tags also. So now this dataset is called the emotida, and the emotida dataset is now having two classes: emotion tags and also the dialogue act tags. So we have chosen 12 dialogue act tags: greeting, question, answer, statement, opinion, statement, non-opinion, apology, comment, agreement, disagreement, acknowledgement, back channel, and the others. And to remove the discrepancy in the number of emotion tags for IMOCAP and mail dataset, the joy tag of the mail dataset was mapped to happy tag of IMOCAP to finally settle on 10 emotion tags for IMOCAP for the emotida dataset. So this is the final statistics of the emotida dataset. There are 1341 dyadic and the multi-party conversations resulting in a total of 19,365 utterances. And each utterance is having three modalities: video, audio, and the text. And these are some of the samples you can see. Like speaker M4 is saying adders don't snap, they stink. Here the dialogue act is the disagreement and emotion is anger. Rachel is saying, well, I just checked our messages and Jesua did not call. This is a statement, emotion is sad. That's very amusing indeed. Dialogue act is disagreement and the emotion is anger. Come on, pick up, pick up. Dialogue act is command, emotion is fear. So, you know, in our data set, IMOCAP contributes 48% and male contributes 52%. And these are the speaker distribution. You can see there are so many speakers: Chandel, Rosh, Monica, Joey, Rachel, Phoebe, others, M1, F1, M2, F2, M3, F3, M4, F4, M5, F5. So many speakers are there. This is the overall speaker distribution. So how emotion is helping? So there are many examples which illustrate that if we know the emotional state of the speaker correctly, then we can easily identify the dialogue act. So for example, I can't leave it, you gauged a hole in my dingy floor. If this is a statement, and if we know that the emotional state is the anger, then the corresponding dialogue act will be disagreement. Okay, so, like the emotional state helps us in correctly identifying the dialogue act. Or if we know, if the utterance is well, I appreciate you coming over and talking to me. I mean, it definitely helps. And if we know the emotion is sad, then then the correct dialogue act is acknowledgement. So these examples illustrate the importance of having emotional information while deciding the dialogue act of an utterance. So the presence of emotion in the dataset caters the models with the ability to use additional information while reasoning about the dialogue act. So now what about the multimodality? So you know that suppose how the multiple modalities or multiple sources of information are helping. So, for example, Phoebe is saying, fine, then you tell Rosa because he was really looking forward to this. So, now text suggests agreement or opinion, and the audio is suggesting comment, and the video is suggesting furious. Okay, so from the text, maybe we will get an there will be an understanding that this suggests an agreement, but when we will see the audio and video, we will see that this is not an agreement, rather this is a comment. So after seeing the audio and video, we will get a better understanding of the situation. Similarly, M1 is saying that's very amusing indeed. Here the text suggests agreement, and the audio is suggesting sarcastic tone, and the video is suggesting slight anger. So again, if we only go by the text, then we will come to the wrong classification of agreement. But after considering audio and video, we will get the correct classification of disagreement. So in both the examples, there exists inconsistency between modalities, which acts as a strong indicator that multimodal information is also important in providing additional cues for identified dialogue acts. The availability of complementary information across multiple modalities improves the model's ability to learn discriminatory patterns that are responsible for this complex process. So next we proposed a multimodal multitask deep learning based architecture. So there are two tasks in hand. So you know that this dialogue act classification is our primary task, and and this emotion recognition is our auxiliary task. And there are this is multimodal system. So there are three types of features that we are extracting: one from the text, then the second one from the audio, and third one from the video. So the transcriptions available for each video forms the source of the textual modality. Written globe embeddings of dimension 300 are used to obtain the representation of the words, and word embeddings of each word are concatenated to obtain a final utterance representation. For the audio features, we use the Open Smile, which is an open source software, and the features are concatenated together to form a 256 dimensional representation for each window, and the final audio representation of each utterance is obtained by concatenating the feature vector for every window. And for video features, we have first used the layer. We have for to elicit visual features, a full layer of an ImageNet pretend ResNet 152 image classification model has been used. The visual representation of each utterance is obtained by concatenating the 4096 dimensional vector for every frame. So then we have used three BiLSTMs. Three individual BiLSTMs are used to learn different semantic dependency features. One BiLSTM learns DAC features tuned in accordance with the emotional features. Second, learns features for the emotion recognition task regulated by the learning of the dialogue act features. And the third, wireless team learns private features for the task of dialogue act classification not influenced by the emotions. And also we have extracted the audio and the video features. Then we apply the attentions, because maybe the entire audio is not important, entire video is not important. So based on the textual modality, we put focus on a part of the audio, and based on the textual modality we put focus on a part of the video. So the audio and the so that this is called the intermodal attention. So concepts basically that based on the text we put focus on a part of the audio, and based on the text we put focus on a part of the video. So we have applied the intermodal attention and also intertask attention. So based on the emotion detection task, maybe some portions of the dialogue act classification are important. So then all the representations are combined, and finally there are two channels. One representation is passing through the emotion recognition channel, another representation is passing through the dialogue act classification channel, and we are classifying. We are getting the classifications of the emotion recognition, we are getting the classifications of the dialogue act classification. So the sentence representation for each of the tasks from the from this triplet attention subnetworks are connected to a fully connected layer, which in turn consists of output neurons for both the tasks. The errors computed from each of these channels are backpropagated jointly to successive prior layers of the model to learn joint features of both the tasks. So this is the overall architecture, that we have the feature representations, then we have the attentions, and after attention there are two channels, and we are getting the dialogue act classifications and also the emotion recognitions. Okay, so basically dialogue act classifications are doing the outputs of the dialogue act classifications, and emotion recognitions are giving the outputs of the emotion recognitions. So experiments were conducted by segregating dyadic and multi-party conversations, as well as in addition to the whole dataset for the multitask framework along with various different modalities. So multitasking framework performs consistently well compared to the single task variant. So we have shown results, but we have done a detailed ablation studies. Like you can see, we have done what will happen with only if we are only using the textual modality, what will happen if you are only using the audio modality, only video modality, or only if you are using the text plus uh, so only with the text plus audio, audio plus video, text plus video, text plus audio plus video, text plus video. So that all the different combinations we have tried. So single modalities and also two modalities. Take only for first the single modality text plus audio, and video, and then text plus audio, text plus video, and then text plus audio plus video, and then text plus video. And also what is happening with the single task and the multitask, like we have incorporated the auxiliary task as the emotion recognition, and the single task is a dialogue act classification. So what will happen if you are solving only the single task dialogue act classification, and what will happen if we are solving the both the task dialogue act classification plus emotion recognition? So these are the two settings we have solved. And then that results are accuracy and the F1 score. And so these are the various results that, and you can see that when you are doing the multitasking, results are much improved. And somehow text plus video is giving us the best result, somehow audio is not helping, and this is because maybe the open smile is not helping at all. So open smile, the features extracted by the open smile are not helpful. Maybe we are not able to extract the optimal set of features from the open smile. So yeah, so these are the various results. So these are some of the ABLA qualitative studies. Like you can see that she is not lady's girl. So here single task is not able to identify correctly the dialogue act, but the multitasking is able to correctly identify the dialogue act. So these are the various results, and you can see the attention is also, we are able to put attention on the correct words. Oh yes, yes, I am. You can't stop it. So when we are doing the dialogue act classification for emotion recognition, the attention is put on the correct word can't, which are important to identify the dialogue act. Yeah. So any question up to this point? Let me check the chat. Any question up to this multimodal dialogue act classification? Okay. So moving forward, so as I mentioned that we developed many other chatbots. So let me now discuss about the development of a chatbot called the sales bot with the help of the Accenture. So we are working with the Accenture lab, and we were developing a sales bot. So what happens is that, suppose we are visiting some online shop like Amazon or Flipkart, and there are many online, there are many many chatbots available, and we are asking, we are putting our requirement. Hi, I am looking for a new phone. Can you please assist me in purchasing a new phone? Then the chatbot is answering, yes, sure. Please let me know your main requirement or specifications. I trust only Nokia brand, so please show me a Nokia brand mobile. It should have at least 16 MP primary camera and large display. Fine. Do you have any more specifications? No, please show me a phone having mentioned features. Great. You should buy Lumia 1520 my Nokia, which matches with your requirement. What would be its display resolution? Its display resolution will be 367 ppi. How much does it have? It contains 2 GB RAM and 16 GB internal RAM. Oh, RAM is very less. It will not work for me. I need at least 4 GB RAM. Thank you. So you can see that these are the general chatbots. Like, user is giving a specification, and if the, you suppose the chatbot is not able to provide the phone of that specification, then you know that so if the, suppose user is giving a specification, and if the chatbot will not be able to provide that provide any phone of the specification, then the chatbot will terminate the conversation. Okay. So but what we need is that there should be a change in the specification in between. The user should be able to change the specification in between. So like for example, user has initially mentioned 16 MP primary camera and the large display, but whatever is shown to the user, maybe the user is not happy with that particular product. So in between, user should have the there should be a feature that user can change the specification. So this is called the dynamic goal serving capability. So end users goals will always align with the virtual agent serving capability. So the end user should be capable of changing the goal dynamically. Okay, so this is the dynamic and persuasive virtual agent. So for example, user is saying, hi, can I help you in buying a mobile? Sure, what kind of features do you want in your phone? It should have 32 GB internal RAM and at least 13 MP camera quality. Is that all features that you need? And color should be gold. Congrats, there is a perfect phone for you. You should buy this Samsung Galaxy C7. It has 16 MP camera quality and 32 GB internal capacity. No, I do not like this color. I want something in this color. And also it is multimodal in nature, because sometimes user is not able to express everything in text. So you know that then user can also show something in mobile, in a image. So for example, rose gold color the user is not aware of, so user is simply showing the mobile the color, and from image, and from the image the bot has to extract the color name. Can you please confirm that you want phone in rose gold color? User is saying, yes, you are right, I love the color. Agent is then giving the option, searching in the database and then giving the option. Then surely you will like Lee Max 2 by Lee Eco, which contains 32 GB internal RAM with 21 MP camera quality. User is saying, yes, it is nice. How much does it cost? Agent is saying it cost only 350 euro. So then surely you will like Limax 2 by Lico, which contains 32 GB internal RAM with 21 MP camera quality. Yes, it is nice. How much does it cost? It cost only 350 euro. Oh, it is too costly for me. I need a phone with 250 euro. No, you should buy Lee Pro 3. So you can see that how it is dynamically changing the specification. So initially the cost was too high. So user is not very happy with the cost. So agent is giving the other option also. So here dynamically the options are changing. So this is a dynamic and persuasive virtual agent, because the agent is capable of persuading the user. So what is the research question here? So existing task-oriented dialogue assistants assume that end users will also always have a predetermined task goal, dynamic goal-oriented virtual assistant. Existing assistant completely flatter in case of goal unavailability scenarios, despite a small mismatch between user goal and survival goal. Persuasive goal-oriented virtual assistant. In e-commerce, visuals are often used to convey requirements when discussing with salespersons, especially for aspects like style and design. So existing assistants completely flatter in case of goal unavailability scenarios, despite a very small mismatch between the user goal and survival goal. Persuasive goal-oriented virtual assistant. In e-commerce, visuals are often used to convey requirements when discussing with salespersons, especially for aspects like style and design. Multimodal persona-aware persuasive virtual assistant. Persuasion target is not enough. Dialogue context also matters. While traditional systems pursued end users with some fixed persona attribute strategy, context-aware personalized persuasive virtual assistant. So this is the now the idea that what we have done is that we have changed the user goal. We have that whenever there is a goal unavailability, suppose the users required criteria are not matching with any of the product in the database, then dynamically the agent will change the product. And also now the user can interact with the agent with the help of multimodality, like not only the textual utterances but also with the help of some images. So necessity rather than preferability. In many domains such as e-commerce, users demand to illustrate their task specification through images. So in this regard we have done some work, and now let me show you those works. So this is our first work. In real world, end users do not have always a predetermined task goal. However, existing virtual agents fail to serve end users dynamic goal and terminate conversation. So sentiment aware task-oriented virtual agent that can recognize goal discrepancy and update end users' goal dynamically. Okay, so basically you know that they are dynamically updating the user's goal. Dynamic goal-oriented virtual assistant that incorporates goal-driven module with traditional dialogue manager. Dialogue corpus for dynamic goal-oriented conversation. So this is our thing that whenever suppose we incorporated discrepancy detector in the dialogue manager. So whenever the discrepancy detector is tracking the sentiment of the user. So suppose the chatbot is conversing with the user, and if suppose the user is not happy at all, you whatever the option and the chatbot is showing to the user, maybe but the user is not happy with the option. So in that case, the discrepancy detector will be able to detect that, and then accordingly it will change the option. It will basically change the goal. It will change the goal. Okay. So these are the two additional things that we have incorporated into a dialogue manager. So it will track the sentiment of the user, and as per the sentiment of the user, it will basically change the user's goal. So this is our proposed module. There is a natural language understanding module. As I already mentioned, it will detect the intent, slot, and the sentiment. And now there is a new thing, sentiment also we are tracking, because based on the sentiment only we will try to understand whether there is a discrepancy or not. So if the user sentiment will become negative, that means user is not happy with the options given by the chatbot. And then accordingly, it will the dialogue manager will accordingly change the options. So we also proposed a data set. We probed existing relevant data corpora such as Multios, ATIS, Barbie, Cornell, Movie Corpus. A detailed discussion with movie retailers, 100 sample dialogue conversations. So we created this data set. Number of dialogues are 1000. Domain is the electronic domain. Number of utterances are 8335. Average dialogue length is 8. Number of slots are 18. Number of intents are 2. Number of sub-intents are 7. And this is a dialogue conversation. Hi, I am in search of a good phone. Hello, any specific phone do you need? It should have a big display and high memory. Is it all that you need? Yes, and color should be black. You should buy F3 by Oppo, which has internal RAM of 64 GB and display size of 401 pixel. What is its primary camera? It is 13 MP. Oh, but 13 MP is less. I take many pictures. Show something with at least 15 MP. Okay, then VP Plus by Vipo is perfect for you. What is its weight? It is 184 grams. Okay, I like this phone. Please pack it for me. A good choice. I am looking it for you. So this way created a data set, and then these are the different models. We used various reinforcement learning based algorithm, DDQA and DD, and also we proposed different reward functions. In reinforcement learning, reward functions plays a very important role. So there are some task oriented reward, and also there are some sentiment based reward. So we used various kinds of rewards, and these are the results: success rate and dialogue length. So in how many cases people are finally buying the mobile phone. And also one objective is that we have to keep the minimum number of dialogues. It's not like that the chatbot and the user will keep on chatting, and so we need to increase the success rate, and also we have to decrease the dialogue length. So the often results suggest that the proposed dynamic goal driven virtual assistant accomplishes the end user's dynamic goal with significant high success rate. Dynamic goal handling capability: the contributed module can be utilized for any task oriented dialogue setting, and task based reward is much more important than sentiment based reward. So next we incorporate the multimodality. As I mentioned, that sometimes maybe user is not aware of some terms. So but user can simply show the image. So from the image, the user has to extract the information. So like user is saying, hi, can you help me in buying a mobile? Agent is saying, sure, what kind of features do you want in the phone? It should have 32 GB internal RAM and at least 13 MP camera quality. Agent, is that all features that you need? And color should be gold. Congrats, there is a perfect phone for you. You should buy this Samsung Galaxy C7. It has 16 MP camera quality with 32 GB internal capacity. So user is saying, no, I do not like this color. I want something in this color. So user is showing a more picture or an image, and now the agent has to extract the color information from this image. Can you please confirm that you want phone in rose gold color? Yes, you are right. I love this color. Then surely you will like Lee Max 2 by Lee Co, which contains 32 GB internal RAM with 21 MP camera quality. Yes, it is nice. How much does it cost? It costs only 350 euro. Oh, it too costly for me. I need a phone within 250 euro. No issue. You should buy Lee Pro 3 Elite, which cost only 280 euro. It has highly rated camera quality of 16 MP with 32 GB internal capacity. It is highly recommended as per your requirements. It's really cool. Please book it for me. Thanks. You are most welcome. Thanks for buying for us. So here user is expressing their requirements through text and also through images. So now our natural language understanding module is not only having the intent and slot labeler and a sentiment recognition module, but also the image. From the image, you have to identify the slots or the maybe the color information or some other slots. So that's why there is the image information module also as a part of the natural language understanding. So whenever the user is saying, no, I do not like the color, I want something in this color, there is an image information module which is extracting the rose gold color, and then that will be the state information. Now this state is given to the dialog manager, and the dialog manager, as I already mentioned, there is a discrepancy. So, the discrepancy manager will basically try to understand whether there is a discrepancy or not. If the sentiment becomes negative, that means the user is not happy with the options given by the agent. In that case, the goal manager will try to show, the agent will try to show the other options. But if suppose the user is happy with the conversations going on, then the basically the agent will try to pursue the user to buy that particular product. So this is the goal manager, and there is a dialogue manager, and then there is a natural language generation module which will finally try to generate the response. Can you please confirm that you want phone in rose gold color? So this is the architecture of the natural language understanding. So we have the state, we have the joint intent and slot module, and which is finally generating the intent and the slot and the image information. And also we have the state and the action modules. So we have several reward functions like task-oriented rewards. So the main task of the task-oriented reward is to solve the task. So if suppose the task-oriented reward is if it is able to solve the task in the required number of utterances, then it will get a reward. And sentiment based reward means that it should be each time the sentiment should be positive. And the persona based reward means that suppose the user is having some you know the user's persona, that user is a photographer. So when the persuasion will happen, it should use the user's persona information, that if the user is a photographer, then the agent should pursue on the camera quality. So that way, the persona based reward is that if the agent is selecting the correct aspect for the persuasion, then there will be a reward. Okay, so do we have used the three types of reward? Task oriented reward means you have to somehow solve the task. The main task is to sell the product. So if the agent will be capable of selling the product, then there is a high reward. And the second is the sentiment based reward. So anytime you should not make the user unhappy about the situation, so the sentiment should always be positive. And the third is the persona based reward. So if you know the some personas of the user, that the user is a good photographer, and then you have to use the camera quality as a as a feature for doing the persuasion. So this is the data set. We have used the domain is the electronics, task is the phone information, phone booking, number of dialogues are the 1000, total number of utterances are 8335, Number of samples in the knowledge base is 2697. Number of attributes in the knowledge base is 018. Examples of attributes are brand, RAM, color, etc. Image categories are color, brand, style, shape, type, etc. Total number of dialogues are 1000. Number of utterances are 8335. Number of instances in knowledge base is 2697. Number of slots 18. And the categories are color, brand, keypad, slide, shape type, etc. And what are the attributes for the brand? We have Apple, Huawei, Moto, Samsung. For color, black, blue, glacier, white, rose gold, silver, yellow. Type, flip, slide, style, keypad, shape, landscape. So these are the various results. So we've added again the different reinforcement learning agents and with various reward functions. And somehow task oriented plus persona based and sentiment based rewards are giving us the highest results with highest success rate, with minimum dialogue length, and the highest average reward. Because in reinforcement learning, we do not use the accuracy or recall or precision. So here for the dialogue manager, our metrics are the success rate, whether the dialogue manager is able to successfully sell the product or not. So in here the success rate is 79%, and the dialogue length is also limited 8.56, and the average reward is also highest. And for the for the image identification module, accuracy is 64.77%, and the intent and the slot modules are having also very good accuracy and the F1 scores. And our finding says that there are some error analysis. For example, that suppose you want to identify the color, but it is identifying the tag as an apple, or you want to identify the keypad, it is identifying the slide. So the proposed reason continues to serve users even in case of goal unavailability and pursues them on some personal aligned feature. And all the three rewards are very important. Task oriented rewards help us in solving the task. Sentiment based rewards are very much important because it helps in making the users happy, like in throughout the process. And persona based rewards are also very important because those are helping in selecting the correct attributes for the persuasion. Yeah, so Rohan, are you there? uh, yeah, so can you allow Rohan to? Okay, Sangeeta. Sorry, there was a question. Yeah. So, yeah, so see, Sangeeta, so the core thing is that we used to arrive to a particular architecture after doing a lot of ablation studies. Okay. So we used to analyze the problem, and then we used to do some ablation studies, like maybe a single model is not always initially we do not arrive to the final model. We used to explore many of the models, and then maybe we conclude to the final model. So yeah, it requires a lot of ablation studies. Or but for example, for this dialogue act classification, there was a requirement to extract the features from all the modalities, and then there was a requirement to put attention on the individual modalities, and then to combine all the features. So we studied the related papers, and there are many papers on the multimodal emotion recognitions. We studied those papers, and then we studied our requirements also. Then initially we were not getting correct results, then we keep on modifying the architecture, and finally we arrive to this final architecture. So it requires a lot of trial and error methods. So Rakesh, are you there, or anyone from the organizing team? Can you please allow Rohan to talk, because Rohan will show the demo now?
Yes, madam. Yes, madam. We are.
Yeah. Rohan, Kirti, can you please allow Rohan to talk? Rohan will show the demo.
Gaurav, please make him as a co-host.
Yes, sir.
make Rohan Kirti as a co-host.
Yes, Rohan sir.
Rohan, are you here? Can you
Yes, ma'am.
talk now? Yeah.
Yes.
So students, now Rohan will show you some demo. Okay, I hope you will enjoy it because demo is also very, very important in this field.
Okay,
Yeah,
I'll
Rohan,
share
go
my
ahead.
screen, ma'am. Yes, ma'am. Uh, is my screen visible now?
Yes, your screen is visible.
Yes,
Yes.
sir. Okay. Uh, this demo is about prompt engineering, like how different prompting techniques affects the output of an LLM. So I'll be starting with the how the configuration of the model is set and what model we'll be using and how it is used on CUDA or GPUs, right? So like we get the credentials from Kaggle. So like these are the some of the codes like since we are using Colab, so we have these packages already installed in the Colab. So we are just importing the user data. So like these are the Kaggle username and Kaggle key. So like for the purpose of this demonstration, I have already put in my Kaggle key and my Kaggle username, which I created by going onto the website of Kaggle and getting the credentials. So once I got the credentials, I just load it. I do it through .get command. So here I imported user data, and then we have this Kaggle username which we fetch from .get and Kaggle key as well. So now in our environment we have these credentials present. So now when we'll load the model, since we have the credentials, it will be loaded into our GPUs. Okay. So moving forward, we import Torch. I mean, most of you would be familiar with this Torch framework. Basically, it is the framework that was um, created by the Facebook. So basically, there are two frameworks. That is, one is TensorFlow and another is Torch. So this Torch framework we'll be using, and also we'll be using CUDA. So CUDA is something that is developed by NVIDIA. So since we are using GPUs of NVIDIA, so these packages like CUDA is also present in the GPUs. Like we are using NVIDIA GPUs, so CUDA is also present. So to check whether we are currently on our GPU or not, so this is the command like torch.CUDA is available and we print it. It says true. It means that whatever work we'll be doing, it will be on the GPUs only. So that's why it's printing as true. Okay, so we are also printing NVCC version. So as I told earlier, we are using NVIDIA GPUs. So we have the NVIDIA here. We are using CUDA compiler driver. And these are the technical details that we are using CUDA 12.5 version. This is something that concerns us at this moment. Okay, so for the purpose of this demonstration, I installed various packages earlier only. So we installed three packages. The first is Torch that I imported just right here. Then we have another package called immutable dict and then sentence piece. So like what immutable dict is like, so immutable dict is a dictionary which cannot be tampered with, which cannot be edited. So once we created initialized a dictionary, suppose we have two entries in our dictionaries like a and 1, b and 2. So if I try to change the content of a to 2, it will not happen because it is immutable. It cannot be edited. So we install these packages. we use sentence piece. This is basically used for tokenization. Like suppose we have a word that I am happy. So each of these words are broken down into tokens. I is one token, am is one token, happy is one token. Okay, so suppose if there is a word called unhappiness, so it may be broken down into two tokens. One is un and another is happiness. So likewise, we have different tokenization schemes also, like word piece tokenization that is employed in BERT LLM. Okay, so these are the packages that we install. What is dot slash dash q and dash u? So basically, when we install a package with pip, we see that it on the output of the this cell, it will say that downloading this package, downloading multiple lines of codes of text are shown. Suppose that we don't want to see that text and simply want to have the like a clear version should be there, like no irrelevant details should be shown, and my package should be installed just then and there without showing any extra text. So that is what we use dash q for. U is for upgrade. We want the latest package of the torch, latest package of immutable dict, latest package of sentence piece. Okay, now moving on to the model weights. So like what is model weights? When we say models, what I mean is the neural networks. So models are also made of neural networks, right? So each neural network has a certain weights and bias associated with it. So since someone has trained this model, they have, while training, the models would have been adjusted by them. So in our case, we are using Gemma. So the Google, it is of Google, right? So Google have trained it and they have kept that model. So we want to load that model on our GPU. So how do we do that? So we are first choosing the variant. So what is variant? So here 2B means the parameters, 2 billion parameters. So we are using Gemma of 2 billion parameter model. So it means there are 2 billion weights and biases in the LLM, in the neural network, in this model, right? So what is IT? IT is instruction tune. Instruction tune, what it is, basically when we have a model, when we want it to behave like, suppose we are like, as ma'am earlier told, we want it to be like a chatbot. I want to give the instruction and should follow that. You are a seller, you are recommending this product, and while posing as a buyer, you have to say these kind of things. So these are what instruction tuned is. The model is refined, the original model is refined such that the instructions are followed in a clear way. Okay, so there can be many variants, like 2 billion, simple 2 billion that I was telling about. So this instruction tune that we have here, it is used, the base model for that version is this 2B, 2 billion model. So likewise, we have 9 billion model. The instruction tuned version is 9 billion instruction tuned IT. We have 27 billion parameter model, and we have the instruction tuned version of that. Okay, so for our purpose, just for the showcasing the different variants that we can use, we have this much variants, but for our purpose, we'll be using 2 billion instruction tuned variant. Okay. So again, for the machine type, as I explained earlier, we have CUDA. So there are two types of machines available, CPU and CUDA. The normal laptops that you guys all have is a simple CPU, and the CUDA is something that we use GPU. Okay. Uh, okay. So what we are doing, we are saying that if the first two character of the variant, the first two character of the variant is 2B. If config is 2B, we put that 2B into the config. So if config is 2B, which means yes, it is 2B. So this will go into this if loop, and we see that we'll rename the config as 2B version 2. Okay. now we have the configuration, the basic configuration as 2B version 2, which we'll employ later. I'll show you where it is used, right? Now, moving forward, what this cell does is that it loads the model. As I told just few moments before, that we have the weights of Google associated with them. They have created it and they have put it in GitHub, right? So now we want to download those weights because we want to use those this model, this gamma model, to run our prompt. So see, the main aim of this demonstration is prompt engineering. So where are we putting that prompt? We are putting that prompt in an LLM, in the model. So what model we are using? We are using Gamma 2 and the variant is 2 billion version 2 model. Okay, so we want to load that model into our GPUs, right? So for that, we are first importing Kaggle Hub. I'm sure that you guys would have heard about Hugging Face or Kaggle, which I'm using. So like Hugging Face, we have Kaggle Hub. So it downloads the model into a certain directory. So this is the directory that I want the model to be saved in, like loaded from the internet, whether from the GitHub, right? So again, these are some just processing that we are doing. So we have this directory, and in this directory, I am appending this file name, right? So we have this original directory. From here we are appending. So the final directory would look like weights underscore dir slash tokenizer dot model, right? Now, what is assert? It makes sure that the directory is present. So like suppose we don't run this line, right? We don't run this line. Okay. And we do assert. It will give out an error because we don't have this directory. Now, in our case, since we have this directory, we have already initialized. So it will not say any error like tokenizer not found. It will work. Okay. So I'll also run this alongside. Okay. So this ran successfully. Since I have loaded the model before, just before starting this presentation, so it took around 5 minutes. So I don't want to waste your precious time. So I'll not run it again. See, you can see it took 5 minutes to load the model. So it is of 2 billion parameter model. So it takes some time to download and load it into our GPUs. So I'll run it again. So what is checkpoint path? What is checkpoint doing? Again, we are doing this. We are appending the checkpoint to the weights directory again. So weights directory would have now two new files. One is tokenizer.model, another is model.ckpt checkpoint. So what this checkpoint does is it basically, like in the general term, if I were to explain what checkpoints does is that suppose that if you are training your model for 100 epochs. Suppose you go till 90 epochs and due to some internet connectivity issue or whatever issue, uh, like your training process stops. So till the 90 epochs, whatever you have trained, all would be lost, right? So what we do is that for all, like suppose in our case, suppose we put a checkpoint at every 10 epochs. So whenever the training happens, every 10th epoch, we will store the weights. So naturally, while training, the weights will be changed, right? So at every 10 epochs, we'll store the weights of the original model. And subsequently, suppose we were using checkpoint during the training and due to some problem, the training stops. So up till 90 epochs, we'll have the neural networks weight stored in our this directory, this weights.directory underscore directory at model.ckpt. Okay, so this is what checkpoint is. So again, similar to this assert, it does the same thing, that if this directory is not present inside the weights directory, then it will say PyTorch checkpoint not found. If it is present, it will not give out any problem. So I'll run it again. So it runs successfully. Okay, so for you guys to understand better, I have attached the FAQs, which I have already discussed. This user data.get, what it does, it fetches the Kaggle credentials. As I told you that you have, if you were to use these model, you have to like go to the Kaggle and create your own credentials. Again, the pip install -q-u. So it suppresses unnecessary output. As I said earlier, various lines of outputs are shown in the cells output. So to make sure that it is not there or it does not bother you, you simply add pip space -q, and u is just simply the latest version of the packages that we want to be installed. Kaggle hub is .model download is the similar, like we want to download the models uh, into our GPUs. Like we want to load the models into our GPU. So it downloads a pre-trained. So again, it's two things. It is downloading the pre-model trained weights, and another thing is loading these weights into GPUs. Those are two different things, right? So here we are only downloading the models. Like suppose that you can understand it in a way that we are only downloading .zip file. Okay, we are not loading that model into GPUs. We will be loading that model later in this code, right? Again, the same thing as what is assertion or the checkpoint for the tokenizer and checkpoint file, the same as I explained earlier. Again, the variants and the machine types specifies the model versions to use. So different variants I have shown, like 9 billion instruction tune, 27 billion or 27 billion instruction tune. Machine type is the hardware that we want to use. We want to use CUDA, that is equivalent to GPUs that we want to use, or whether we want to use CPUs or not. Okay. Okay. So we have downloaded the models here, right? We have downloaded the models in the weight directory. Now, to access that model, to make sure that we can utilize those model, so it needs certain packages and libraries. So Google has itself created a GitHub repository of Gamma PyTorch. I'll like clone it again just to show you. So like I actually ran it earlier, so it is already present here. So that's why it is saying that already exists. So the previous the output that was shown here, that was the original cloning of this repository. So this repository is this one. This repository Gamma in PyTorch is the lightweight state-of-the-art model built from research and technology. So this is the like uh, more or less you can say the specifications that we want to use to load our model, right? So again, small session of FAQ, what is git clone? So like if you were to use any GitHub repository, you can clone it to your desktop, clone it on your server. Like I'm using Google's server, so I'm using cloning it in the Google server here. So the git clone command does simply this. So it downloads the entire Gamma PyTorch repository to the local environment. The local environment here is of the collab that I'm currently using. Okay, so yeah, so good question that emerges here is that why is repository cloned instead of installing a packages? So like earlier you would have seen that I did pip install sentence piece, right? So why didn't I use like pip install gamma 2? Why didn't I use that? So we do this because like some of the models that Google's have created, they might not have put it the specifications, they might not have put it in the hugging by the Kaggle itself. So they have put it somewhere in the GitHub. So we want to use that to run our model, right? So that is what GitHub is doing here. So what if happens if so these are the basics GitHub commands, GitHub questions. So suppose if Google were to change this, so this is the repository they created. Suppose they now change it to Gamma PyTorch 1. So naturally, when I try to load it through this, it will not load. So it should be the same. Like, it should not be private. Repositories can be public or private. It is public right now, so that's why I'm able to use. It should not be deleted. So it's not deleted, it's present there as I've shown you. So that's why it ran easily. So it didn't give out any error to me, right? Um, so the repository is saved, like cloned in the Gamma PyTorch directory that we have. So that is where our repository, the contents of those repository, these files are stored, right? Do I need to run this command every time? Not necessarily. Once it is cloned, like cloned means you have downloaded it to the your environment, like your directory. So you don't have to download it again and again. Okay. So since we are using Collab, it may be necessary, like you have to um, uh, reclone it again and again due to the runtime that we have. Suppose I do what I do is disconnect and do delete runtime. So in that case, I have to again clone it to my virtual environment in my local directory. Right. Okay. Now moving forward, like there are certain, now since we have loaded this GitHub repository into our local directory, now we'll start using that. Okay. So we import sys, which is the inbuilt Python module. And what we do now is that in the original Python module, we simply append this Gamma PyTorch that we have implemented, downloaded from the repository, like cloned from the GitHub. So now with this, we'll be able to use different Gamma's capabilities. Like here we can use the configuration, the model, the tokenizers, right? So since I appended it to the original Python module, now we can use this Gemma config. So basically we need to configure our Gemma, right? While loading the model, there needs to be certain configuration that we have to look at, right? So those configuration will be seeing, right? So okay, so suppose that if I didn't run this, if I didn't append this uh, Gamma PyTorch into the original Python module, all of these would not run. It would give out an error. I have checked and it does give out the error that unable to find Gamma or something like package errors like that. So since we have ran it, and if I run it, it runs successfully. So here we are doing three things. From the .config file, we are importing Gemma config and get model config. These are the inbuilt packages that, like, once you are exposed to the coding in the PyTorch framework, you'll get to know, like, it would be of much more understanding of what these uh, packages do in, like, uh, do while implementation. So as you can see that Google have already made this, we are just importing it. So you can see here that there are certain things, like it is a class, obviously it's a class, it has architecture, what it has vocabulary size, something that Google would have defined. It has tokenizer, like the tokenizer.model that we have earlier made the directory of. We have numerous arguments present in the Gemma config. So we are not creating it from the scratch. We are simply importing what Google has created because we are using their model. We want their configuration to be used here. So that's what we are doing here. Okay. So get model also, it takes in the string, and the type is a string of 16-bit float integer, right? So these are what we are loading. Again, here Gemma for causal, we have this model that is a simple convolutional neural network uh, that takes in one input and two outputs, and we have this forward layer. So all of these are imported by Google's own package. We are doing nothing new. Again, the same Gamma PyTorch, what it does. As I said, it adds Gamma PyTorch directly to the Python module search path, allowing the script to import modules like the modules that we have loaded here, like gemma.config. So this is what it does. What is the role of Gamma config? So it manages the config, as I told you earlier, it manages the configuration settings for the Gamma model, such as architecture details. So here all the architecture details are present, right? Here you can see that gamma.config.architecture. All of these are defined by Google's, and we are just importing it. Okay, again, as I showed earlier, it is a class. It says that it is a class that implements Gamma model for causal language modeling task. So what is causal language modeling task? If I were to get into the basics of causal language modeling task, what is causal language? So whenever LLM generate output, it's not like they generate parallelly. Suppose I say, what is the capital of India? The output of the LLM would say something like, the capital of India is New Delhi. So what you are seeing as a result is this whole line, one at a time. But what happens behind the scene is that it generates one at a time. For in the first iteration, it would generate the. Again, in the next iteration, it would generate capital. Again, in the next iteration, it would generate is. So likewise, the capital of India is New Delhi. So one at a time, one token at a time is generated. So this one token at a time generation is called as causal language modeling. So like GPT, you must have heard GPT, generative pre-trained transformer. All those are causal language modeling, basically decoder based models. Okay, so that is what. So that's what we will be also be using. We want our model to generate in the causal way, right? So we'll be using Gamma for causal, just to have you for your understanding why we are using for causal LM. Okay. Again, this is Torch is a core library, PyTorch core library that was made by Google. So, like, why do we use GPUs, not CPUs? Right, this question can emerge. So we use GPUs because it is very good at one thing. One thing that GPUs are good at is handling the tensors. Whatever we want to do tensors with the tensors, like we want to multiply tensors. Suppose we want to multiply two tensor of 16,000 cross 16,000 with another tensor like matrix of 16,000 cross 16,000. Now you can understand how big of a matrix it would be. So each of the elements needs to be multiplied. So if I were to multiply it in our CPU, it will take around 10 to like not 10, like 3 to 4 minutes to multiply these two matrix of these dimensions, 16,000 dimension. But if I were to multiply it in the GPUs in the form of tensors, it would take around 5 to 6 seconds at max. It will, or at max 15 seconds to multiply this tensor. So this is what GPU specializes in. So at the core level, if you were to understand the neural networks, that's what we are doing, right? We are multiplying the weights with the input that we receive. So those weights are in the form of matrix and it is multiplied with the input. So this matrix multiplication happens very fast in the GPUs. That's why we are using GPUs here, not CPUs, right? So this is what uh, Torch handles. So Torch basically handles all of these like deep learning tasks like this, right? Context lib, I don't think I have used, so I'll ignore it. Yeah. So earlier I told you that we did we have to do two things. We earlier downloaded the models into our local directory. For your understanding, I said that suppose we downloaded it in .zip file. We did not, but for your understanding, suppose we downloaded it into .zip file. Now we want that model to be loaded into our GPUs, right? Okay. Wait a minute. Okay. So before we load the model's weight, we want to utilize the configuration that we have earlier made. So this configuration we have earlier defined here initially. So the configuration is 2B-V2, 2 billion parameter version 2, right? This get model we imported here, right? So we pass the config 2 billion version 2 into our get model config. It is a like it takes in the string, which is a string, because here we are giving string, what we are giving 2b v2, and this is our model config we have. Now in this configuration that we have now, we for the tokenizer we have earlier defined the tokenizer path. So like, where have I defined the tokenizer path? Yeah. So okay, this is this one only. Okay, so we are initializing here itself. Okay, we are initializing the tokenizer path here itself. Okay, now what is quant? So like, these models that we load are it takes up certain GPUs, right? So I'll show you just in case. So here I'll write what is my, okay, it's not install, wait. Okay, so that dash q that I was telling about you, that suppresses unnecessary output. So it suppresses all of these. Suppose I didn't want this, I would simply write here pip install dash q, and all of this would not be shown here, right? So this output corresponds to this command and this GPU stat. So I'll run it again. Okay, so we have a GPU of 15 GB provided by Google Tesla T4. Suppose we are loading a very big model. You would have heard about Llama and all, right? So suppose we are loading 18 billion, 7 billion parameter model. So naturally it will take around 14 GB or 15 GB. Like suppose if we were to take 12 billion parameter, it would take around 22 to 25 GB. We don't have that much space. So you can understand what quantization does is that it compresses those model weights such that it fits into under this GPU. Okay, so that's what we have done. These are the configuration file that we have created. Okay, uh, we are like instantiating the model weights. So here we are using the device as CUDA. So machine type I earlier defined here is CUDA. As you can see, CUDA. We want the device to be CUDA. Gamma for causal is the same thing as we imported up here. Gamma for causal, right? This is the model config that we put in. This is the checkpoint. Now we are okay. This is the line that is of utmost importance in this cell, right? We are loading our weights into our GPUs now. Okay. So when we load the model into a GPU's weight, it takes around 5 GB of the VRAM, the GPU, right? So we have this in our GPU now. Now we put it into the, so basically we have loaded this model. We have the models, the tensors. Now we are loading it into the GPU. And why are we doing eval? Why are we using evaluation? Because we are not doing any training as such right now. We are only inferencing. We have loaded the pre-trained weight. Now we just want to inference it, right? So that is what we are doing. Again, these are the FAQs corresponding to all of these, right? Predefined configuration, get model config, it retrieves the predefined configuration of a specific model variant. Here we have 2 billion version 2, right? The so all of these models like 2 billion, 2 billion IT, 7 billion, whatever models, they would have different architecture. They would have different number of layers. So what are layers? So like mostly these are all of these generative AI models are decoder layers. So there are not just one decoder layers. So there are suppose, I don't know if you would have heard about LLM about Mistral AI. So that is a 7 billion model, right? So it has 32 decoders layers, right? So if you pass the input, it goes through 32 decoder layers before it generates the output, right? So this is the number of layers that we are talking about right now. Again, the tokenizer, we have assigned the tokenizer path for processing input as text. We want the input to be broken into different tokens before feeding it into our models, right? So that's what this is doing. This is what quantization is, a technique to reduce the size and computational complexity of the model. That's what I earlier told, right? Suppose if you some model is taking 40 GB of VRAM. Now we want to load it in a quantized version. So it will take around 14 GB of the VRAM. So there are different quantizations. So there are 4-bit quantization, 8-bit quantization. It depends on our GPU's access, what kind of models like quantization we want to use. So again, why did we set it to the evaluation mode? Because uh, it places the model onto the specified hardware. CUDA for our case, we are not using CPU, optimizing computations. Again, we are using GPU. We are using GPU obviously, but we are not using in the training mode. We are using in the evaluation mode. So like this dropout is a function of training. Like dropout is used in while training our model. So since we are not using it, we are disabling it by model.eval. Now comes our part of, now we have loaded our models onto the GPU. You can see the GPU is utilizing 5 GB of VRAM. We have the models in our GPU now. It's running well and good. Everything is working fine till now. Now we'll be doing inferencing, right? So the prompt engineering demo that I am giving right now, it starts from here. This was all the pre-processing, loading the model with certain configuration. We have done that, right? Now we are inferencing. What we are inferencing means that is we are giving the prompt to the LLMs. You would have used ChatGPT, right? You give the prompt, it gives the output. But how is that possible? You are not configuring any LLMs, right? You are simply putting in the text prompt, you are getting the output. That LLM is provided by the OpenAI API key. Like they have the OpenAI, in the OpenAI, they have the LLM stored. They have in the GPUs, when you say give the prompt, in the GPUs of OpenAI, it runs and it gives the output, right? So our case, we have model at our hand. We have the text prompt that we'll be inserting, we'll also be getting the output, right? So now we are using the instruction tuned gamma model, right? So for basic example that I want to show you is that we have annotation of tokens here. So user here in this code, we have user, that means user is speaking. Model means model is speaking. Start of the turn. So start of the turn means when the user says, we'll say the start of turn. When the user end, we'll say end of turn. What is EOS? EOS is nothing but end of sequence. Whenever the dialogue turns, it says end of sequence, right? So I'll give you one example. So we have created a chat template, right? User chat template, that we have start of user, start of turn. We have user, because user is providing. We have the prompt. This, mind it, we are using it in the curly braces, so this means it will be replaced with the original prompt we'll be having. So this is a prompt that I later in the code I have shown. And now one turn has ended, the user has spoken, like suppose user has said what is good place for travel in the US. It has, the user has said now his turn is over, so I have written here end of turn and end of sequence. Now similarly for the model part, we have start of return, because again model is again starting to say something. So we have start of turn, we have model, we have one line we have provided in between. We have the prompt. Again, what is the prompt that we give in the model? We give the model California, right? Again, end of turn US. So this is the simple chat template that I have created, right? So now I'm creating a full-fledged prompt that I want our input to go, right? So you can see that we have chat template, you have user chat dot format. So in place of prompt, we are providing what is good place for travel in the US, right? Good. Now we are doing model chat dot format. We are coming here and we are giving California. Again, we are adding, going to user chat template. We are giving prompt. What is the prompt? What can I do in California? So look at the bigger picture. All of this is a prompt and it is stored in this variable. Now I'm printing this variable, right? So this is what my prompt looks like. We have user, basically it is more or less like a conversation history. So we say that what is a good place to travel in the US? It says California. User says, what can I do in California? So this is the prompt. We are printing it. Okay. So I'll run it again. So it printed the prompt quite fast. You can see it is now taking some time to generate. Why do you think it takes time to generate? As I told you, it is a causal language modeling. It is generating one token at a time. So that is why it is taking a bit of a time to generate the text. Now this goes into our model. It gives out the output that, so it is giving in tandem, like what can I do in California? It says California is an awesome place. Here's a big breakdown to spark your travel ideas, split into categories: nature and outdoor, national parks. These are the national parks, and the list goes on, right? So it gives out a proper response that I was expecting, right? So one thing here I want you to think of is, what is device.device? So earlier we have initialized that our device would be, I don't know where I have initialized, but I have initialized somewhere. Let me see. Okay, I can see here itself only. Okay. Okay, yeah. So I have initialized here. You remember that I have initialized machine type as CUDA. So device is CUDA. So we want our all of these template that goes, I want it on CUDA. So we want the device on the GPUs. What is output length? So we want the output length to be of 128 tokens, right? So we are telling the model that whatever you want to generate, good for you. It's it's your capability of generating, but I want it under 128 tokens. So it created it under 128 tokens, right? This will be much more clear in the just next subsequent cells, right? Okay, again, the FAQs here, these are nothing but the same. We have user chat template, model chat templates. How is a chat prompt constructed in this code? This is all I have generated. So model.generate function is what is inferencing from our model. This is the main syntax that we are using to generate the function. These are the simple placeholders that we have used. Okay, so instead of prompts that we have used prompts here, we have defined such a big prompt and we are just putting it prompt. We could simply write the prompt here like we have done here. Write a poem about an LLM writing a poem. Okay, so it writes an AI born of court's delight, awakened to think, learn and write. So you can see that it is trying to generate in a poem way. It starts with this much, it goes on to the other line. It says this much, again it, so this is following the poem's architecture, like how the structure of the poem is written. So it is smart enough to understand, right? Okay, we are using here 200 tokens to generate, so it's well and good. All of these are the same things, right? Okay, now what we are doing here is, instead of doing model generate every time, we are creating a function called generate function that takes in the prompt, whatever prompt we will pass, and the output length should be 100, right? And we are returning the generated text. So this portion of the code will generate the text as shown earlier. So we have the prompt that will be coming as from the argument. A model will be generating the response and it will be returning. So this is example. So suppose the prompt is write a poem about the beauty of nature. It goes into our prompt function. It generates the responses, it returns, and that response is returned into this one. And when we print, we'll get the output. So you can see we have printed response 1 and response 1. It is printed here, right? Similar, we have done write a romantic poem about the beauty of nature. Same thing, it is present here. Okay, so there are different role assignments in prompt. So you can assign a role. You here I have seen that you are an environmental poet. Write a heartfelt poem about preserving forest. It does that. It will generate, right? Uh, so it is not generating. I'll run it again. Okay, I haven't run this cell. So it took time to generate first response. It is taking some time to generate the second response. It generated. So it has generated the poem. Okay, so I'll run it again. See, it has created the poem, written the poem. Again, you can see that it cuts abruptly here, stops abruptly here. Why does that happen? It happens because we have set the output token as 100. Okay, so suppose that I put the output token here as 150 and again run it. You can see a bit longer poem, but again it is cut. Again, if I'll do 200, it will again give a big poem, right? So it's something like this, how we are truncating the output of an LLM by output length 150, right? Again, now we have COT, chain of thought prompting. Suppose we want our model to, it basically it thinks one at a time, right? It says that thinks logically step by step. I'll run it. So you can see that it is saying step 1, definition of forest, importance of diversity, climate regulation. We are asking why is preserving forest important? We have importance of diversity, we have climate recognition, so regulation. So all of these are given step by steps. This is called as chain of thought prompting. Few shot prompting is nothing but we are providing examples. We are making our models aware, giving exposure to certain examples, right? So here I have given the examples. What is the capital of France? We have given Paris answer. What is 5 plus 2? 2, 7. We have given answer as 12. So we have given two examples. Now I am asking who wrote the Hamlet? It ran and it gave William Shakespeare. Right. I'll run it just in your case. Shakespeare. Right. Using constraint. So like suppose I want our model Gamma to write about technology and its fact, but using 4 lines only. So as you can see, we are putting in some constraints and the model is following this constraint, right? Automatic chain of thought. Earlier we had chain of thought, right? Usually we give the all of these chain of thought, the reasoning steps in the prompt also. In this, in the automatic chain of thought, it generates on its own the reasoning steps, right? So suppose I say I give a math problem, a train travels 60 miles in 2 hours. What is its average speed? So you can see that it broke down the calculation in certain manner. Like it first wrote the formula, speed is a distance by time, 60 by 2, 30. So it came to a conclusion after certain steps. Right. Now we have self-consistency. It generates multiple reasoning path and pick the most consistent one. Right. What is 23 multiplied by 7? So we have, it says first is understanding multiplication. It says that multiplication is about repeated addition. So 23 multiplied by 17 means nothing but adding 23 itself 17 times. This is one way of one reasoning path here, right? Another is we on a number line, we start at 23, add 17 spaces to the right. This is second reasoning path. The third is repeated addition. We are adding 23 17 times. Third, right? That's what it is doing here. So likewise, it is giving out multiple reasoning steps and choosing the best. So this is what we are doing. Now logical COT. I'm sure that logical reasoning, all of you would have solved one at one point of a time, right? So it is similar. If A implies B, B implies C, does A imply C? Explain your reasoning. So again, this is a classic example of truth table being useful, right? How can we approach this? Implication. It gives out different steps like the reasoning that it has incorporated while generating the response, right? Okay, so that again it gets truncated because the output length token is 100. We have graph of thought. Again, the logical reasoning, we have Alice is Bob's mother, Charlie. So we have three variables, Alice. So what is graph? In data structure, you would have gone through graphs. We create three nodes, Alice, Bob's mother. We connect it in a way that depicts the family relations with each other. So likewise, our model is able to generate the response like Alice is Bob's mother. This establishes a line of inheritance from Alice to Bob. We say that represent the relationship graphically, but Gamma may not be capable of generating the response in such a way. So it is giving in a text form like, okay, this means this establish a line of inheritance. Okay. RAG is something like we suppose we have a PDF, right? We want to, with that PDF has the uh, product names and price. Suppose I provide in the PDF and say that what is the price of this product. It will go into that PDF, see what is the product name, price, it will fetch it and then give it. This is what RAG is, retrieval augmented generation, integrate external knowledge for better generation. It is also used for uh, uh, countering hallucinations in LLMs. Chain of knowledge, right? Chain of knowledge, what is chain of knowledge? I'll run it. So we are giving two facts, right? We have given two facts here. Uh, Water boils at 100 degree at high altitude, boiling point of water is low, right? Now we have two facts available. It uses those two facts to generate the output. So I'll give you an example I've written here. We have the question, why do whales comes to the surface to breathe? I have given these facts. Whales are mammals. Mammals breathe air using lung, therefore must surface. So our agent takes in the knowledge, chain of knowledge. First chain, second chain, third chain. It takes this chain of knowledge and then it generates the output that because whales are mammals and use lungs to breathe air. Similarly, we have these two facts. It is generating the reason that boiling point of a liquid is the temperature. It is giving the results corresponding to these two facts. Again, it gets truncated because we have the output length set as 100 token. Emotion is something that we want to induce the emotion. So write a letter to friend, or you can write a prompt something like that. Uh, Write a letter to my brother that I'll be not be able to visit this Diwali, and it makes my heart feel very sad that I'll not be able to do that. It will invoke the emotion in the response. So again, here is expressing joy and excitement. So it says that I just won a competition. I'm still reeling from the incredible excitement and can't believe I actually pulled it off. So it is providing the emotions. Emotions are being shown in the outputs. Scratchpad is intermediate. So it would feel like intermediate computation steps as a scratchpad. So it more or less it is closely related to chain of thought prompting, but it is a bit different because um, it uses more of a technical terms. Like we say that at the ones place, or like given this, we are doing this. In chain of thought, you can say that first we are doing this, now we are doing this. So we are explaining our reasoning thought process in the human language. This we are restricting ourselves to the very formal terms, like at the ones place, at the tens place. So this is more or less related to the chain of thought prompting, but in the syntax, like the wordings that we are using, the difference comes there. It is called scratchpad prompting. Program of thoughts is nothing but you simply write a Python function, calculate the factorial of a number. It gives the Python code and also explain that n is an integer that is being passed here. The factorial of n is output is factorial of n. So here it gives the factorial of 5, it gives out the output of 5 factorial. Also providing the explanation for what it did. Structured chain of thought prompting is more or less also similar to the scratchpad. Okay, so here also we are using consistent, often numbered, labeled format, breaking into reasoning, like define the rules, given the rules, apply the rules to solve this problem, identify the variables. So these are like, as I told, the goal is to do this more formal terms. Basically, it is numbered or categorized. Chain of code is just instead of explaining a solution in natural language, in chain of thought, as I told, first did this, and then I did this. Instead of natural language, it uses Python, like structured pseudocodes, right? So it gives out the instruction that what this function is doing. The function is sorting a list in ascending order. The numbers are this. The new list, what it returns is a new list of numbers, right? So it gives out the what the numbers we are going to input, right? So optimization. So we suppose that our some code is running at O of n square. We want to optimize it to O of n. So we can do it through prompting also. So this is a very simple case. So we are running the loop from 2 to n. We say that prompt optimize this code. So what it does is that it optimized by running the loop at from 2 to 0.5 n plus 1. So from 2 to n, it runs from 0.2 to 0.5 n plus 1. So in a way, it has optimized because it is not running for as much iteration as it was previously. Rephrase and respond prompting is like before giving the output, the LLM gamma model here, what it rephrases the input questions to better understand and clarify it, and then generates the response. So suppose if we have the original question is what are the best ways to grow tomatoes, the rephrased version would be how can I grow healthy productive tomatoes. So if we are rephrasing the original question and then providing it as the input, and it generates the response which may be of uh, better use, like better readability or better understanding. So it gives out like this. Take a step prompting is something that suppose generally the LLMs like ChatGPT does calculation mistakes. So you should not rely on the calculation of the LLMs solely, right? So we see that you calculated it this much. Take a step back and reevaluate your calculation. We are just making sure whether the LLMs that they have generated the response, whether they are correct or not. We are asking the gamma itself, see whether it is correct or not. So because the general mistakes that occurs, that where the mistakes might have, I can provide the correct answer, what mistakes might have occurred. So it gives out the output that possible mistake is incorrect use of multiplication sign, incorrect use of calculation sign, performing the calculations. So it it didn't run for wait, total length is equal to 200. I'll run it again. Yeah. So it gives out the explanation that it appears that the uh, mistake likely originated in a simple arithmetic error when performing multiplication. If you use calculator, it's crucial to uh, double check your calculation, because see 12 into 15 is not 160, it's 180. So it gave out one method that it could be a simple arithmetic error. When I run another, it could give out some another way of giving out the like understanding how what error could have happened. Yeah. So again, next time I ran this, it says that maybe it happened due to the misplacing of decimal. You might have accidentally placed the decimal point incorrectly, leading to the incorrect answer. So likewise, this was what prompt engineering are. These are the different types of prompt that we can incorporate to maximize our interaction with the LLMs, right? So this was the demo from my side. Uh, so
Thank you, sir.
does,
You can ask questions if you want, sir.
yeah, if anyone has
Everyone.
questions, they can ask. Okay, so pip install why we use pip install? Because we want, see, GPU stat is, you can understand in a way, it is a package. To check the utilization of GPU, we are installing this package, and that is done through pip install. So this is a basic syntax that we use to install any packages. That's why we do pip install, and whatever the package name, suppose we want to install pandas, we'll do pip install pandas. So that is, so you can see that earlier when I ran GPU stat, it didn't give out any output. When I did pip install GPU stat, we installed the package in our environment, and when I ran it again, it gave out the GPU utilization. So basically, we are installing that package in our environment. Also, what is instruction tune? So basically, for a certain type of tasks, we want our LLMs to follow a certain way of, suppose we are creating a chatbot, right? We are creating a conversation of chatbot. When I say that for the seller, you have to recommend the product, you have to assuage the concerns of the buyer, you have to make sure that the buyer is moving forward towards making the purchase. So when I say that, all of these, I want our LLM models to understand all these instructions. So these are what instruction tuned models are. Over and above the base models, we fine tune it on the instruction tuned models. Like for a, like in the chatbots, we fine tune it using a chatbot, using a data set that would have certain utterances of the conversation. So what GPUs we have and how much we have utilized. Yes, yes, GPU stat shows that thing only. No, fine tuning is like totally different thing. We are just checking the utilization of GPU by GPU stat. Fine tuning is something like we have the model, we have the weights, we are providing in our data set, we are adjusting the weights according to our data set, that such that the model is now able to understand. Yes, instruction tuning is like more or less a way of fine tuning. We are fine tuning. Thank you so much.
Thank you, sir, for
Any
your
other
valuable.
questions? Okay. So I don't think there are any other questions.
We conclude, sir, then.
Okay. Thank you
Thank you,
then.
sir. Thank you, sir, so much. Sir, there was a small request. Would you provide this demo code for our participants?
I'll share with Sriparna ma'am. She will share it with you. Okay.
Sure, sir. Thank you so much, sir. It was very engaging and very informative.
Okay. Thank you.
Mhm.